A duct booster fan can work, but does it work is the wrong first question. The better question is, what is limiting airflow at this branch? A booster adds pressure at one location. It cannot repair a disconnected duct, open a crushed section, clean a filter, create a missing return path, or correct every central blower problem. This video starts with the root cause, then shows a controlled way to decide whether a booster belongs in the solution. It makes no universal airflow, temperature, comfort, energy, sound, or payback promise. Start with the whole air path, not the small fan. The central blower pushes against resistance from filters, coils, trunks, branches, bends, dampers, grills, leakage, and return air restrictions. Their intersection with the fan's pressure capability establishes an operating point. Adding a booster can move that point for one branch, but the size of the change depends on the complete system. A free spinning product on a table does not predict delivered airflow in a real duct network. Before buying hardware, run the root cause ladder. Confirm the complaint is real and repeatable. Check the filter and central equipment status. Verify that the register and balancing damper are open. Look for a kinked, crushed, disconnected, undersized, excessively long, or leaking branch. Check whether closed doors or a weak return path change the symptom. If the cause sits upstream, fixing the cause usually gives a cleaner result than adding another motor downstream. Here is what a booster can and cannot change. Installed in a suitable branch, it can add local pressure and may increase flow through that path at its new operating point. But air comes from somewhere. Pulling harder on one branch can change pressure and flow elsewhere, especially in an unbalanced network. A booster is not an airflow generator independent of the system, it is another fan working in series with the main blower and the resistance around it. Two products often share the booster label but occupy different locations. A register booster sits at or near a room outlet and influences the terminal end of a path. An inline booster sits inside a duct branch and needs suitable access, mounting, controls, electrical provisions, and service clearance. They are not interchangeable evidence. The company-owned image here is one inline product form example with an external controller. It does not prove compatibility, installation method, output, savings, safety, or fit for your duct. Now build a fair baseline. Hold the HVAC operating stage, central blower setting, filter, registers, dampers, doors, and measurement location constant. Let the system reach a stable condition, then record several observations over the same time window. Repeat the same sequence with the booster enabled. If you change a door, filter, fan stage, probe location, or runtime between tests, the comparison no longer isolates the booster. A credible before and after is controlled, repeatable, and documented. Measure the quantity you actually need. A single velocity reading at one point is not automatically branch airflow. Velocity varies across a grill or duct, and converting it to flow requires a defensible area and method. A flow hood, a qualified traverse, or another appropriate instrument may be needed. Comfort is also not one number. Air temperature, room load, mixing, noise, and operating cycle matter. Record method and uncertainty instead of turning one display value into a universal CFM claim. This short company-owned bench clip uses smoke only to make movement visible. It is a qualitative visualization, not a field installation, calibrated airflow measurement, pressure test, sizing proof, or promise that a booster will solve a room. The label area is intentionally masked, the source audio is removed, and no instrument value is shown. Use this kind of visual to explain direction and path, use controlled measurements and system information to decide performance. Placement and control need professional review. The booster should operate in a way compatible with the central system, not fight a closed damper or run against an unavailable path. Wiring, interlocks, access, insulation, condensation conditions, fire and smoke boundaries, duct materials, and local code can change the permitted solution. This is not a mains wiring, control board, or duct cutting tutorial. Dryer exhaust, kitchen grease exhaust, combustion venting, and hazardous exhaust are separate applications and are outside this video. Check side effects before calling the test a success. Listen for new tonal noise or vibration. Recheck other rooms for stolen airflow. Check whether doors change pressure balance, whether the central blower cycles differently, and whether the new operating point remains acceptable across normal system stages. A higher reading at one outlet is not automatically a better whole house result. Commission the network, not just the boosted branch, and keep the booster accessible for inspection and maintenance. Use this 6-step decision card. 1. Define the weak room symptom and target quantity. 2. Verify the central system and return path. 3. Inspect the branch for restriction, leakage, damage, or poor balancing. 4. Establish a stable baseline with a documented method. 5. If a booster is still justified, select and place it using system pressure, duct geometry, controls, access, and manufacturer instructions. 6. Repeat the same measurements and check every affected branch for side effects. The verdict is conditional but useful. A duct booster can help when a specific branch needs additional pressure and the rest of the air path is known, suitable, and measured. It is a poor substitute for repairing the actual bottleneck or balancing the system. Before ordering hardware, write down the suspected cause, the controlled baseline, the measurement method, and the post-change acceptance checks. Bring that one-page record to the HVAC professional reviewing the site. Diagnose first, add pressure second, and verify the whole network last.